Okay, so you wanted a network design with the headquarters and three branches. So
Yes.
the headquarters was to be located in London. The three branches are like Manchester, Portsmouth, and Cambridge. And based on the requirements, we anticipated that the headquarters will have many users than the branches. So when you're designing when you're doing a network design, you make assumptions. So one of the assumptions that I made is that the headquarters will be having many users than the branches. So and also one of the most important thing that our server farm or data center is located. Our main data center is located in the headquarters. So the headquarters here has how many departments? Apart from the server farm, it has five departments, which is front office and service department. It also has a restaurant department. It has admin, management, and IT department combined. It has sales and marketing, and finally HR and finance. And you can see each department is in a different network. Like you can see here, for example, front office and service department as is we like I said, assumptions. We assume that in the future this department will have 200 users. So we design a network with future consideration. Even if it's expanded, we won't have any problem. Then with 200 users, now the new network will be 1010 that one slash 24. Then we expect this department to get IP addresses from DCP server, and the DCP server is located here on the server farm. So also the department is having a VLAN 10. So the same case scenario applies to all the departments in this network topology. Each subnet represents a department. It has a specific network, the expected number of users in future, and also the VLAN number. So if I can just take front office as an example, and I want us to go bit by bit. We start from the users level to the firewall level. How the traffic will be flowing from the user to the firewall, and from the firewall back to the user. So like I said that front office and the service department will be in VLAN 10. So this switch here, that switch, all the interfaces of that switch should be in VLAN 10, such that any computer or any host device that will be plugged in or connected to that switch will be in VLAN 10. So how to verify that? You can just go to that switch, you come to CLI, then you hit enter. When you hit enter, you will encounter a prompt for password. Just write Cisco. You will not see the password, but it's written in the background, and you hit enter. Then software department switch enable. Then Cisco again. Now show VLAN. So you can see we have front office VLAN there, and it has these interfaces from FA0/3 to FA0/24. So those are the switch ports that the normal user will connect to our network. Then you can see there are some two interfaces on this switch here, FA0/1 and FA0/2. So this one should be trunk because you can see they are connecting to multi-layer switches, the two multi-layer switches. So among the things that we configured here, the professor might ask, what did you configure on the access layer switches? So I used one to demo for all because we did nearly the same thing for both of them. Okay. Among the things that we did here, you can just say show start. When you say show start, the first thing that you will see here from here is service password encryption. So service password encryption is a command that is used to encrypt all the passwords that you configure, such that when someone logs into this switch, or let's say the way I'm logged in right now, and there's a friend of mine who comes and maybe is well conversant with Cisco configuration. When he reads my password, he might be able to log into this device. Maybe let's say he reads this one, username, which is Cisco, and the password, which is this one. He or she might be able to log into this device and might compromise this our network. So to prevent plain text password, or to encrypt those passwords so that they appear in unreadable format, you encrypt them, and the command that encrypts them is this one, service password encryption. This password here is encrypted. I used Cisco, but now Cisco has been encrypted to this unreadable format. Yeah. So another thing that we even this one has been encrypted. Cisco has been encrypted, that one. Another thing, now what I'm talking about is basic settings. The first level is always basic settings. So I know, let me just, I don't know whether I have the, okay. So these are the benchmark. This is what we're going to use to explain everything. We created the can you see my screen?
Yes.
Yeah, we created the topology which is now here. So we need to explain it bit by bit. So it's hierarchical network design. Hierarchical network design means that it has access layer, a distribution layer, and the core layer. So here, the access layer is the layer that is connecting the end devices from here now, going this way, where there are access layer switches. And now the distribution layer. We have the distribution layer at the center, where there are multi-layer switches. Then we have a very, very huge core layer consisting of the routers, the core routers, the HQ routers, the core routers here, and the firewall. Both of these are core layers. From these routers, these middle routers, and the firewalls, both of them are core layers. Now we don't talk of ISPs. We don't control ISPs. We only talk from the firewall going down. So if I can say that, if I can repeat, this is where the access layer switches are the access layer. Where the distribution layer switches are is the distribution layer. And the core layer is comprised of the routers and the firewalls. So I've done explaining the hierarchical network design there. Oops. I'm sorry, I opened that mistakenly. That's meant for, there are some guys who want to join our company, so we need to give them a test.
No worries.
Yeah. Okay. Then we go to connecting networking devices with the correct cabling. So as you know that nowadays it's very recommended. It's recommended that we connect devices with the correct cabling. For example, at the access layer, you can connect computers to switches using straight through cable. This is a straight through cable. A cable is with the dotted is crossover. And crossover cable is used to connect devices of the same type. Switches. Switches comprise of layer 2 switches and the multi-layer switches. So whether it's a switch, it's a crossover. But when you connect devices of different types, for example, switch to routers, switches to end devices, you use straight through. Even routers to firewall, you still use crossover because they are multi-layers. They are co-layer devices and layer 3 devices. They can both carry out to nearly the same functions. So you just connect using straight through cable. So let's say we want to connect our branch, or when we are connecting our branch to the core routers, we just use serial cables. So here we use serial cables. So I know the professor might ask why you used serial. Well, serial is used for high speed, just like fiber. We use serial for high speed connection. So to achieve high speed connection between the branches here, to achieve high speed between the branch network and the core routers, we use serial connection. Yeah. So if I go back here again, I'll have to close this first. Oops, I closed all of them. Then we go to stage D, basic settings. It's very, very important because I configured nearly the same basic settings for all the devices. What will differ is just few or two things like naming and where it connects. So I said that I'll demo with the software department switch. So to see the basic settings, just say show start. Okay. And like I said before, this service password encryption is used to encrypt passwords. Then we have host names. Among the things that we configure here, I think I explained on the documentation that I sent you earlier. I explained there on the documentation. Among the things configured, you can see here now. You can basic settings includes host names, banner message line, console password, privilege mode password, VTY password, SSH, username, password, domain name, dislabeling, IP domain lookup, exit timeout, login synchronous, and finally we encrypt all the passwords. So the professor might ask you where to show him where the configs are. The first thing you do, just say show start. Then you move here. This one is the last part. Service password encryption is always the last part. You encrypt all the password after you configure them. You cannot encrypt what you've not configured, so it should come the last one. So the first thing you can say, you configure the host name. For example, this was a front office and service, so I just shortened it as soft department switch. And enable password. So enable password is the privilege exec mode password. Then we go to SSH. We configured SSH version 2. Then to disable IP domain lookup, we said no IP domain lookup. And IP domain name. Our company is called, maybe it's lancaster.com. So that's our domain. Then to log into these devices remotely, we have to create usernames and password. So our username is Cisco, and the password here is encrypted, which is Cisco. Also, when you move down, you just pass this one. Just move down, yes, until you see this one. So banner message. So this is a banner message. The banner message is like a warning. Before you log into this device, you receive a warning. Yeah. And then line console password is this one, plus the exact timeout and login synchronous. Line VTY password is here with the exact time, and I didn't put exact timeout here. So here, what is here is just SSH. For you to log into our VTY interface, you will use SSH as the remote access protocol. Okay. And then part E is creating VLANs. Like I demonstrated earlier, how to show VLAN. You just say any of the switches. These settings applies in all the switches. Just say show VLAN. So you can see the VLAN name here, VLAN 10. It's named front office, and the interface that are under VLAN 10 are these one. So that's achieved. Creating VLANs and assigning ports VLAN numbers. We have VLAN 10 and these ports are under VLAN 10. Okay. So creating both. Unfortunately, I didn't do this. Unfortunately, I didn't do that. I just created because of time. I just created the normal VLANs. I didn't create the voice VLAN as per now.
Okay, no worries. I'm gonna leave this one.
Yeah. So subnetting and IP addressing, I believe I sent you the table here. This is the table. Very, very simple. It's very, very simple. It's very, very simple. This is the table I sent you for the. I have already done it, so it's very, very simple to understand it. So for example, let's say the firewall and ISP router, it's this network. This firewall and this ISP router is this network. So this table will just help you, just guide you know how they were configured, because I understand you know a little bit of subnetting and how I did it. Yeah, it's not that much very difficult. Yeah. So this is the addressing table, which is very, very important in every networking network documentation. You have to include this. And another thing also is inter-VLAN routing, both on the switches and on the routers. So here, I only did inter-VLAN routing on the switches. The reason why I wrote on the routers is because of the voice VLAN. But because I didn't configure voice VLANs, there was no point of doing this. So I'll just demonstrate inter-VLAN routing on the multi-layer switches, which is called SV high. So when I go here, you choose any switch here. For example, this one. Come to CLI and Cisco. Enable Cisco. Show start. How to see the inter-VLAN routing configuration. So these are the inter-VLAN routing configuration. How is the inter-VLAN routing done? We create VLAN interfaces. So for example, we add how many VLANs here? VLAN 10, 20, 30 till 60. So we create VLAN interfaces. So for example, VLAN 10 interface VLAN 10 to represent our this department here, software, front office, and service department. Then we give the description, and we assign it IP address. So this IP address is the one that will act as the default gateway of front office department. So it's 10.10.01. If I can just go and hover over any computer here, you can see that the gateway here, the gateway is 10.10.01. Then IP helper address. So IP helper address here is used for DHCP. So being that the the DHCP is located far away here, we must give these computers a way to reach our DHCP. So we tell their default, remember interface VLAN 10 is the default gateway of front office department. So whenever this computer will need IP addresses, the first guy that they will ask is interface VLAN 10. So when interface VLAN 10 receives that request, it will forward it to this guy here. You can see IP helper address. So this is the IP address of the DHCP server, which is this one. You can see it's 10.10.1.230. So that's very simple, and the same applies to all of these, all of them. Yes. And another thing that dedicated DHCP server device for data to provide. So how did we configure DHCP server? So you can just demonstrate. You can click on the DHCP server, you come to services, then you go to DHCP, and here you find the pools that were created. So for example, let's say this one is front office, so I'll search front office, which is soft. Yeah, so you see we created the pools based according to the department. So let's say front office pool, the default gateway is the IP address of the VLAN 10 that we created. Then the DNS server is that one. Okay, DNS server should not be that one. Let me just click on this web. DNS. Okay, that's why I didn't oops, where is that? Okay, where's DNS? Okay, yes, so DNS server is having a IP address of so I'll copy that. I come to DHCP, and the DNS server should be that IP address of that DHCP DNS server, and I will modify and send this this for you later. So you can see if you try to hover over that, you can see that the DNS server is saying 10.10.1.230, which is very wrong. The DNS server should be IP address of this DNS server, which is 1.231. So if I can just go here again, go to desktop, then IP, I turn it to static, then to DHCP again. So I want to see if you can pick 231. Yeah, so that's right. So if I can just try again, try to go to the website, our website, which is hosted here. Our website is hosted in this HTTP server. So the website was lancaster.com, and I hit enter. Lancaster, sorry. Yes, you can see Royal Lancaster, London, things like that, because the website is hosted inside our HTTP web server here. So where was I? I was okay, DCP server. So I was just saying that for you to configure DCP, you come to services, you create DCP, and you create pools. So for example, this was front office. I'll just use that as an example to represent all of the above. So we use default gateway, which is the appearance the interface VLAN that we created during interval routing, and then the DNS server, and you give the starting. I heard that so you are telling me something about DCP, the ranges of appearance that we need to use there.
Yes.
Yeah. So let me just read your message so that I can send it there. Just a minute. Actually, I'm not feeling well at all.
I'm really sorry about it.
Yeah, I have a lot of
I'm
work.
extremely sorry.
I have a lot of work. I'm the network administrator, so you know, the previous system administrator left, so I have the two roles now. I'm having a lot of work.
Oh,
Yeah.
a lot of pressure.
Yeah. Previously I was the network administrator, so when the system admin left, I had to take up the role. So a lot of work.
Okay.
Yeah. So you are asking me how many IP addresses that you can allow. It's written
Yeah.
here. So if you click any pool, you will find the maximum number of users there. If you click any pool, you'll find them there. So that's the numbers of IP addresses that you can allow.
So I can customize this one.
What do you mean customize?
I mean, if I want to increase, can I?
Well, in this topology, you won't have to increase it. You won't increase it unless you change the subnet mask. That is
Okay.
determined by the subnet mask. So you
Okay.
have to change the subnet mask first.
Mm-hmm.
Yeah, for you to edit this one.
Okay.
Yeah. All right. Okay. And then another thing, configuring routers as DHCP server for voice. As I said, actually, unfortunately, I didn't do voice here because it's a lot of work. And you said that your deadline was a few days ago, so I had to hurry and do it without including voice. So
Okay.
yeah, so anything going with voice, we'll have to skip. Then we configured either channel using LACP. So how to demonstrate that? You can just go to any multi-layer switch. Either channel where you see LACP written is where you demonstrate. Even
Okay.
on this side here. Let us demonstrate here.
Mm-hmm.
Come to CLI, then write Cisco. Cisco. So just show either channel, just that's all. And you will see that we are using group 1 either channel, and the maximum number of ports that are used there are 3, and the protocol is LACP. To show more details, you can just say show either channel detail or summary. Yes. So when you say show either channel summary, you will see the ports that are used to form the either channel. In this case, it's these 3 ports. So that's very easy. Just say show either channel summary.
LSCP for load balancing.
Yes, it's used for load balancing and redundancy.
Okay.
Yeah. So SSH for secure remote access. So you can remember we configured SSH, but you told me I should include V2 access control list for SSH. So I'm going to explain all those. So let's just explain with this switch here, the one that I've just opened. It was, I think it's this one. Yeah. So we just can say show start. The first thing, we use SSH version 2.
Mm-hmm.
Then scroll down until you meet VTY interface. So VTY is where we use SSH, and you can see we created an access control list for SSH. Here, access control list 1 to only enable IT department subnet to connect to remotely access the devices, but denying any other subnet. This is the only IT department subnet.
If in the system there is any technical issue, only the IT department can access this.
Yes, so we will demonstrate that also.
Okay.
So this access list is inserted here in the VTY because it's the VTY interface where SSH happens. So you have to effect it there. You have to put it in the VTY interface. So you can see in the VTY interface, I have put SSH and access control list. So that's where SSH will be done, and the access control list will take effect whenever SSH is done there. So to demonstrate, we take IP address of this switch here. Any IP address, we just hover over it like that one, and you can see we can take the first IP address, which is 10.10.4.93, and you go to any computer. Let's start with this computer, which is just right over here. Go to desktop, you go to command prompt, and you say SSH -L. Then the username is Cisco, but the IP address is 10.10.4.93, I think so. If I hover again, yes. So when we try to connect, you can see remote host, a connection refused by remote host, because access control list is preventing it from allowing connection from any other device other than the IT department. So when you go to IT department, which was combined with the admin department, let's just take even this tablet here.
Mm-hmm.
Let's use the tablet from admin department IT. Then we come to command prompt, then we paste, and I hit enter. So you can see I'm being asked for password, which is Cisco.
Mm-hmm.
Here, then you can see end of Cisco. Yes, so you can see we are in Manchester multi-layer switch 2 from admin PC, which is our IT department PC. So that's how to test it. Just a minute. Put on your car. So. Okay. Nyamaza basi. Basi. Chukua simu kidogo. Chukua simu. La kuwekea.
Yes, I can hear you. No
Yes.
worries.
So that's all about SSH. So we go to SPF. So SPF was configured both on the MAC layer switches, the routers, and the firewalls. So to demonstrate SPF, you will go to any MAC layer switch, router, or firewall, and you can just say exit. You can exit. You can just say show start first. There are three ways: show start, and you will see your SPF here. So basically, SPF is used to advertise the directly connected networks. So for that MAC layer switch, we only advertise the directly connected networks. So another way to show it, you can just say show IP OSPF neighbor, and you can see all the neighbors of this router, all OSPF neighbors of this router there. Or you can just say show IP OSPF summary database, and you can see all the database content in that area. Yeah, so that's how to show OSPF. It's very simple. Then standard access control is for VTY interface. I have just done this right now for SSH. Access control is for SSH. Then finally we go to PAT, which is port address translation. This is in the firewall, and standard access control list for PAT. This will be in firewall, so I'll explain firewall later. Anything going with voice, as per now, we didn't do. And also configuring a site-to-site IPsec VPN. So how to verify how we configure site-to-site VPN is very simple. So here we have and show start. Yes, how we configure site-to-site VPN. So these are the parameters from configuring site-to-site VPN. So you can see we created a policy number 10 with the encryption algorithm of EAS length of 256. Then authentication to be pre-shared and a group 5. So so this is the IP address. You can see crypto, that one VPN. This is the key content referring to this address, which is the IP address of this router here. So to understand it better, we move here. You can see this IPsec VPN is configured to connect to SQ network, and the IP address of the peer here, which is the IP address of the SQ network, 10.10.461. So if you can just go here and see where 10.10.461 is, you can see it there. You can see there's a 10.10.461 there. So this VPN will connect to this router. This router will connect to this router, and they form a tunnel, a VPN tunnel, using the above parameters. So after they have formed a channel, all the communication between the HQ and the branch networks will be secured. So to verify if it's functioning, just say show crypto IPsec security association SAR. Oops, there's no SAR here. Just a minute. Show start. You can go here and test. show crypto IPsec. So oops. It should work. I don't know why it's not here. No, so far. Okay, I'll check on that. But the configuration are already there, but now there's no content of encryption, and I'll check on that. So standard access control list for ACL. So if I can just go back to this router here, let's say the Cambridge router, and we say show start. You'll see there are some access control. So these are the access control lists. The access list 10. So those are the access control lists for IPsec VPN. Those are the access control lists for IPsec VPN. And now, what size now? Now let's go to the firewall. Let's finish with the firewall. So on the firewall, there are things that are called interfaces, security zones, and levels. So if I can go to the firewall and let's say enable. Now for the firewall, there is no password. You just hit enter. Show start. So the concept of security levels, zones, and we assign them IP addresses. So you can see interface, this interface, this one, the name is inside, it has a security level of 100. So this is the interface. Where is the firewall? So any interface that is connecting to our inside network should have higher privilege or this priority, security level of 100, and we assign it to IP address. Any interface that connects outside should have the least privilege or the priority. So that's how it works. We had two inside one and inside two, because you can see the file connecting to two routers which are inside. So here the going down is our inside network. Now from the firewall going up is our outside. So that's all about the interfaces, security zones, and levels. Then I talked about creating PAT or the NAT. So this is the configuration for creating NAT, PAT, port address translation. So we first create an object network, we name it, then we give the subnet that we want it to translate, and we tell it to translate using the dynamic interface. And also it's very, very important to, whenever you connect to any ISP, it's very, very important to configure default route the way I've done it there. Then we create access control list the way I've said here. Where's the access control list for firewall? I didn't do it here. It should be there. Access control list for firewall or the security policy. Yeah. In creating inspection policy on the firewall. That's done using access control list. Then this is now a way of putting this access control list, all of them, to an interface, and we are putting them to outside interface because we want any traffic coming from that outside interface to be inspected. And another thing here that I configure on the firewall, the OSPF. You have to configure OSPF on the firewall to enable the devices to form neighbors and advertise the directly connected networks so that there will be communication in the network. So lastly, I'll explain how this topology will work, because that's the most important here. I have explained to you where to find the configuration and how it was configured. So I will explain how it works. So when we start from the access layer, in the access layer, what you configure there is the basic settings and the VLANs. Basic settings and the VLANs. So we configure the basic settings here and the VLANs. So each device belongs to a specific each end device belongs to a specific VLAN number. So for example, these devices here belongs to VLAN 10. This devices here belongs to VLAN 60. This one here belongs to VLAN 80. Sorry. And so on and so forth. So you have to say that in the access layer we configured only basic settings, VLANs, and most importantly SSH. We can also configure SSH. Whenever we configure the SSH, we have to restrict it, access control list. That's all. Then when we go to distribution layer, we configured inter-VLAN here, inter-VLAN routing. Then we configured LSCP either channel here. We also configured OSPF here. And finally, these smart layer switches are configured as DHCP relay agent. What that means is that whenever they receive any request of IP address assignment, they forward that request to DHCP server. So you have to know that all the multi-layer switches are configured with inter-VLAN routing. SSH is very important, OSPF is very important, either channel is very important, and as a DCP relay agent. So let's go to the core routers here. The core routers basically just OSPF, basic settings, SSH. That's all. These routers here, all the routers in the network. You have to know that all the devices first of all the devices in the network, they have all the devices in the network. Mostly, when I say all the devices, I exclude computers, all the host devices. I only talk about multi-layer switches, and the routers. So all the switches, multi-layer switches and the routers, both of them have basic settings. They have SSH. Yeah, and they have access control list for SSH, for VTY or SSH. So when you go to these routers, all they have is just basic settings, SSH, and access control list for SSH. Then you go to firewall. Firewall, the same way it has OSPF very fast. Although I didn't configure basic settings on the firewall, it only has OSPF, firewall policies, access control list, and now all of this that I explained here. All of this, yes. So that's all. So before any communication,
Okay.
yes.
Yeah, please.
So before any
you say.
Yeah, before any communication happens, these computers will require IP address. Remember, these computers here are in VLAN 10. So whenever they require any IP address, they will forward the request to the multi-layer switch. And inside the multi-layer switch, there is an interface for VLAN 10 that we created during inter-VLAN routing. So whenever they forward that request to that interface VLAN 10, that interface will say, oh, I'm not the DHCP server, but no, I know a guy which is the DCP server. It will forward that request to DCP server, and the DCP server will forward the IP parameter to the devices. Once they have obtained IP addresses, let's say front office on this side wants to communicate with the sales and marketing on this side. So the same way sales department has gotten IP address. Remember, all of these sites are getting IP address from this server here. All of these sites. If this server is not here, these sites will not get IP address. So you have to know that it's only this server that allocates IP address to all of these devices in the network. So whenever this computer, front office computer, want to ping with any other branch, the traffic will first go to the switch. And remember, it's a VLAN 10 by default. So VLAN 10, the switch will forward that traffic to interface VLAN 10 on either of these multi-layer switches. When that interface VLAN 10 receives that IP address, it will forward it to any of the. When that interface VLAN 10 receives that packet, it will forward it to any of these HQ routers, and the HQ routers will forward it to any of these core routers, and the core routers will put it down to its respective destination. But when traffic wants to go outside, instead of coming down, it will go first to the firewall. Then the firewall will put to the SP router, and the SP router will put to the cloud, and you will meet the connected end users. So that's how it's going to. Maybe if you have any question that I need to explain.
Can you hear me?
Yeah, I can hear.
Okay. So you explained very well. And in this project, I need to know what are the limitations and what is the problem you have faced during this design.
Well, the limitation of this project is the cost, because for you to purchase all of these devices to facilitate the communication is not very easy, because you can see in each department you have a lot of devices, so we require a capital and maybe a very big data center to put all these devices. So the problem that I faced when configuring, you can say it's about IPsec VPN, but that's going to work. That's really going to work. It's going to work. I just want to make it work right now.
Okay. No worries.